much for a final.
Your final request?
Yes,
A
my
final
request.
request.
More, I want more partial credit. A positive for a negative,
That's drawing.
minus 3 points. I lost half credit. It's on camera, posterity.
Yeah, I didn't really hit you heavy on that. I thought about it and I wanted to, but
I thought that was
just hit
heavy.
half. I just hit half.
Your definition of heavy and my definition of heavy are different.
I just don't think there's any mercy in this class.
Yeah. Well, it wasn't that you made a sign error. If it wasn't a multiple choice question, then you would have just been docked 1 point. But because you chose the wrong answer, I don't really have to look at your work. I can give you 0 because you chose the wrong answer in a multiple choice test. But I found 3 points by looking at your work. That's how it evolved.
I see your point.
Yes,
No pun intended.
yes. You don't see your points though.
It hurts because it's true.
Yes.
Are we getting that little box on our test of,
No, but you need
C
that little
equals
box.
R
You
and-
need those little boxes to do your test. You mean, am I giving them to you?
yeah,
Oh, no, that's gotta be internal, that's gotta be part of your life from now on.
What little boxes are you talking about?
The row squared, the
this,
DBs.
the conversions, the cylindrical, spherical, coordinate, rectangular.
No, those you know.
So you won't give me the fact that r squared equals x squared plus y squared?
I won't give you that, no. I'll
Or
give you the
that-
nerd
No, that's
t-shirt
the
though.
easy one.
Is it, well, is like x equals alpha sine? Or is it
Something
sine?
like that, something like that.
I can't
You can draw
remember.
little triangles and figure them out.
That takes so much work.
AJ, are you increasing your height over the last 2 years? You've grown an inch or two since we've met.
I swear I've shrunk. But
Oh, that settles that, okay.
I swear
Look at you
I
guys
started
draw,
shrinking.
will you?
No,
You guys
it's
are,
as we get older, we shrink, and
top
then it
drawers.
looks like they're taller.
I'll look forward to it.
Okay.
I could have sworn I've been shrinking.
No, man, you're looking right over the top of the whiteboard now. I think it's your posture, guy. I think you've learned how to stand up.
What does that mean?
Took you 20 years.
You
huh,
are, you're
AJ?
straight now.
You're straight.
Yeah, you are. Yeah.
Give me that finally honest.
No, you're standing proud and tall, not half your height.
I used to stand with a more straight back when I was in high school, but that was
And
because of ROTC.
Well, you're back to it now. I guess it's Calc 3 does it to people.
It's all
Stiffens
that.
your
It's all
spine.
those compliments you've been giving him on his whiteboard work.
This
This
is
confidence.
worthy and deserving of it. This is awesome. I'm really impressed by your guys' drawing ability, though. That's what I was trying to draw, and look how Stuart just knocked it right out. See that cone with ice cream on top? Should have been those.
Are you doing 19?
No, he's doing 16, which mine looks something similar. I just don't have the cone part. I have the cone, I don't have the ice cream.
Cone's pretty dry.
Yeah, I'm gonna guess mine is an upside down cone. Yeah. today I had to put.
I did not hear the word put,
I heard poop.
I heard poop.
You heard poop?
Yep, I
No,
heard poop.
today I had to put a pill in a pit bull's dog, mouth to swallow it, cause there were pets sitting for someone.
Mhm.
That was gross. Just to let you know for the record. Did I tell you I had short-term memory?
What?
I have short-term memory.
What?
Tengo memoria corta. Sumimasen? I don't know that one.
Would you mind checking my minutes?
Hi, number 11? Intersects C equals R squared in a circle of radius 2. The volume consists of two portions, one inside the cylinder, R equals 2, and one outside that cylinder. They seem to be indicating that you're going to have trouble without a drawing, but still you have two pieces. So the first piece is minus this, and it stops at R squared, and it goes from 0 to 2 pi, and 0 to 2. Now the other piece goes from 2 to the square root of 20, and it goes from minus to plus. Now you see, what went wrong was you didn't visualize the
It's in
volume,
here.
so you didn't
Oh, you
know you
got
had
it,
to
okay.
break it
What
into
number
two
is,
pieces.
are you doing?
You just tried to convert the limits.
Oh, that's
And
really
It's a
just
cylinder
not
inside a
like
sphere.
Well,
That's
no,
what
it's
I
not
have,
drawing the
but-
visualization.
And then what do you do?
You have
So
to
that's
know
our-
what it
that's our
is,
square,
and
then
once you
leave
know what it
zero.
is, you recognize you
Okay,
have to
then
break it
that's
into
our
two
problem.
pieces.
Okay, that's what I was trying to figure
Okay?
out.
So this is R squared plus C squared equals 20, is a cylinder, agreed? It's a cylinder that goes straight up, out the x-axis. No, R squared plus C squared equals 20 is a sphere. Okay, that's a sphere of 20, okay? And Z equals R squared is a paraboloid.
I don't know. I
Is
don't
a
know what that is.
paraboloid just like this, okay? And, now, this goes up forever. So this, Z squared, R squared plus Z squared equals 20 is a
I don't know what
sphere
that
inside.
number is.
One inside the cylinder, R equals 2. Z equals R squared. 1,
You're close.
the volume, and we start up to 20.
That needs to be 2 and that needs to be a 32. But it is quite close.
One inside the cylinder, R equals 2. Z equals R squared. Z equals R squared. In a circle of radius 2, the volume consists of two portions. One inside the cylinder, R equals 2. One inside the cylinder, R equals 2. Z equals R squared in a circle of radius 2. This has a radius of square root of 20, which is around 4. So where do these guys intersect? R squared, Z squared is R fourth. R squared plus R fourth equals 20. Okay, now that has to be equal to R squared.
That should be a 4.
So now you you square both sides, and you get R fourth, square both sides, R fourth equals 20 minus R squared. So R fourth plus R squared minus 20, R fourth plus R squared minus 20 equals 0. That has solutions, R squared plus 5, R squared plus 5, and R times parentheses, R squared minus 4. Now, these are the only ones that you look at because those are negative. So R squared minus 4 equals 0. So R equals plus or minus 2. Okay, so you know how we did that algebra, right?
Yes.
So this is where they intersect at R equals 2. So this is a sphere, and it intersects at R equals 2. And at R equals 2, then R equals 2, it has a certain height. Okay, so we can draw this in profile. Yeah, I'm going to draw a profile in the front row. So this is section.
As long as it's close enough, that's all that matters.
That section should be a 2, but everything else is correct.
1056, number 11. So what we have is a circle, and rho is equal to the square root of 20. Then we have a paraboloid, which goes like this. And it intersects at R equals 2. R equals 2 is the intersection, right? And so this point has R value of 2, and what is it? That is inside the surface of the sphere, but not above the surface, not above the surface. Okay, so they do not want to do this part, they want to do the lower part.
I figured out what
What?
the angle is before, but I don't remember how I got it.
So
Yeah.
they don't want to do this part. They want the volume that's down here, okay? So the volume that's down there, you have to go from here to there, true? So it has a lower limit here and an upper limit there. So that's your value of Z. True? Now, that's your value of Z only
So
until
Tony,
you
you're
come
supposed to
out to
find
here.
out the, use
True.
the Southern Post.
Now, after you come out to here, your value of Z is from here to here. Just the points in the sphere.
Yeah.
So you see, you have no chance at all of doing this without a
I probably should have done
So your integral has 3 pieces. First, this piece,
Like,
and that piece are gonna be the
It's
same.
well, that's
So you can just
spherical.
double them,
Cause,
right?
well,
So what
it's
is the
gotta-
limits
gotta
on
take
Z
that
here?
No, I
Limits
said
on
I don't
Z
solve
here
them, I just find the
is,
limits, and he's like, that's the
square
important
root
part.
of 20 minus
Ah,
R squared. 'cause
so I
that's
set it up
sphere,
as
right?
spherical.
I did
And
Southern
2 minus,
Post.
and 2 is plus.
So it's
I got the 0 to
minus
pi,
R squared. So
but
that's
I
going to be the
negative
limits,
2 to 2 for
and
R,
that's going to
and
be,
my Z is
between,
negative square root of 9
this
over R
point here
squared
is
2
the square root
square
of
root of
20,
9
right?
R squared.
so it's going to go from R being the
20.
square root of it's going to start here at 2.
Negative
It's
3 to
gonna
3.
stop at
I
So
think
that's the
square root of
original.
20.
These are, this
So
is the
that's
original,
going to
this
be
is
this
like
piece
a.
right here.
I think it'd be, how do you get two?
Because R starts here, right?
Yeah.
What is the
This is-
value of R2? And what's the
So it's a
value of R
circle,
here?
it's just a flat circle with a
No,
sphere on
square
top
root
of it,
20, right?
and from the
Yeah.
XY, you know that the circle has radius 3?
Yes, I'm done.
Okay, Okay, good.
And then also
Now,
in
for this
cylindrical,
piece right here,
R isn't negative, it's still just,
the limit on the
It's-
bottom
it's
is
0
going
to
to be the
2,
circle,
and then
which
you
is
go all the way
e to
around.
the square root of 20 minus r squared.
do you want me to show
But
you?
it's gonna stop here.
Alright, so,
And what's the equation of that is
ignoring the fact that all my other numbers are wrong.
z equals r squared, right?
Yeah, well,
So it's
that's
gonna
how you
stop
do
the
it
R
in
squared.
spherical, I would just need to convert the
The
middle.
actual,
Now, the value of r is gonna start here,
This is R, right?
and it's gonna stop there.
But
So
R,
we're gonna go to 2.
R only has a positive value, so it goes from 0 out to the edge. So at any point, it's from 0 to 3. So,
So on this which
Oh, I'm just doing half of it, I'm just doing this piece right here.
and then the angles, you're doing the full circle.
Oh, well,
there are
so,
times
no,
that
when I get
in-
to theta, I'm gonna do the whole thing.
when
This
you're
integral,
doing-
I'm doing the green arrows right now.
Polar?
In the
No,
green
that's not the
arrows,
right word.
this is the
Polar
line
coordinates,
Z.
cylindrical coordinates,
It starts
whatever.
down here, right? Z is,
If you do
minus
0 to
20
2 pi,
minus r
because you're
squared.
doing the
It
full
stops
circle, like
here.
if you're doing cosine,
but the
you'll
equation
get
of this
the
curve
value of
is
0
Z
because you'll be
equals r
subtracting the same
squared,
number.
right? So it
So you
stops
should
on r
do 2
squared.
times
Now, the values of
theta
r,
equals 0 to theta
um,
equals
you
pi.
have to look at the footprint.
That way, you don't
What's
have
the
to worry
footprint?
about, like, if something falls out in the future, you can fix that. And then the z value,
The footprint in
what
the
is z
xy
equal
plane,
to?
r goes from 0
Z goes from
to
0,
this line, 2.
and then it goes up to,
Then theta goes all the way around. Theta goes all the way around. So there's no chance to do this one without a drawing. When you get the drawing, you realize the pieces you have to break it into.
here that also.
Theta also goes 0 to 2 pi.
The original
And
is.
this is
Because this is an outside
9 minus
shell.
x squared
No,
minus
no, you don't need 2. Sorry, this r goes from,
minus
that's a 2. R goes from 2 to the square root of 20.
So-
Yeah, that's a 2.
now that can,
Now,
That
and
can't
you
be
don't
right.
need to double
Z
it,
equals-
because when you do theta goes all the way around, this is a belt. So you get a belt that goes all the way around.
So this plus this.
That's right. Two pieces.
Very
Very hard problem.
Z squared plus r squared equals 9.
well, I guess it can be strict conversion.
Nice drawing. You guys are good drawers.
So, does that make sense? So, like, that's why I started drawing them all out, so I can look at it on a picture, so I can see this is a circle. So I know how much of the circle is being used, and then
My drawings, these are not fun. Sometimes I can picture it, sometimes I just can't.
is that when you go for Almond Joy or mountains?
Okay, other
Okay, let's see how these are doing.
people's work. So it should go from.
What's wrong?
AJ, you remember when you internalized?
Yeah, you're good at this.
When you internalize these DVs, what was the DV in cylindrical coordinates?
The equation r dr d theta dz.
Right, her R is a little faint, isn't it? Do you think she should make it darker?
Yes.
Well, that's because it comes down here. And so are you saying that becomes r squared over 2?
I'm saying, there's just, there's an R there.
Well, yeah, it's just an r, but I'm saying that when you take this limit of this equation, it's just that.
Then it's R squared over 2 when you,
Then it's r squared over 2.
that's
Okay.
what it's telling you.
Okay. That's what I'm talking about.
That's what friends are for.
You're such a good friend.
I found my best.
So those problems are removed when you start memorizing what these little DVs are. That's why it's required by your intelligent instructor that you memorize these, and he doesn't give them to you, and you forget to write them. But if I give them to you, then you don't forget to write them, right? Okay, so
I have
13,
one.
Oh, you didn't have
row
one?
equals something.
Oh, that part doesn't even match.
Oh, row equals 0 to 4. 0 to pi over 6. Okay, those are well done. 13 is impeccable. 16 seems to have you in a quandary.
Maybe how much you got?
I know that's what it is, but I don't remember how I got that. So I'm trying to remember.
Maybe that'd be
I'm
it.
just trying to figure out how to make my triangle
I have
work.
these two switched.
Oh,
Like
so
I have
then
the
is
1
it
and the 0 switched, not that thing, I just have this 1 and that.
typo?
Well, what's the shape? Looks like an ice cream cone, is it?
Yes.
Because that ours.
You just want the volume in it?
Yes. And so I'm trying to figure out how far down
Oh,
B goes. And
I
they gave
didn't
me,
do the integral, just
what did they
this.
do?
Well, what's the given information?
I'm given a cone and a sphere. I know the sphere at the, here, like, if it were to continue out would equal 3. So I know
So
it's
a
less.
radius of 3.
Right.
And what's the info on the cone?
The cone is square root of x squared plus y squared.
Equals z?
Yes.
So z equals r. So it's a 45-degree line.
Oh, well, so I got it.
Z equals r, it's a 45-degree line. Yeah, you don't go with the 9 for the cone. Well, you found the point of
Yeah, because
intersection.
of,
You need that.
This,
Did you find the point of intersection? Maybe you shouldn't erase that, because that's gonna be needed too. So you know that z equals r is going to be there, but you don't start, oh, you want to start with rho. Well, rho is always going to go to 3, there's no question about that. Now, theta is going to go to pi over 4, because this is a 45-degree angle, because z equals r, agreed?
I was doing it in spherical.
Oh, well, I'm just loosely
Okay,
speaking,
yes.
z equals r
Yes.
establishes that's a 45-degree line.
Yes.
It's a 45-degree line no matter your coordinate system, so I just established it from the most handy
Right.
one.
Yeah.
So this is pi over 4 and it stops at pi over 2.
This is
Well,
gonna be
phi
2
starts
pi
here,
because it's
so it goes from 0, phi is 0 here, so it drops down to
I
pi over
had-
4.
I have those upside
When
down.
he
Yes.
said,
I actually see it
this
as
is what,
this is
from what I
the
remember,
lower limit because it's
when he
lower.
said the last
Alright.
integral, it's always a solid
Yeah,
integer.
it's measured down from the z-axis.
It's not?
It's not.
Not by make it over here.
I don't know.
Okay.
Is it always,
One
is
thing
it
is-
too high?
Why is?
Interesting enough,
you have
they
to
agree
say
with you,
here,
they go
but you're
up to the
evaluating
pi
it
over
far.
2.
Yeah.
We'll come
So
back to that in
these
a
two would
moment.
be switched.
But you see, they also
Because
get
this
the
would be
9
the
for
theta
the
integral,
rho squared, which
and
should
that
be
would
rho
a
cubed.
typical R.
Yeah, rho 0 to, they go pi over
Yeah, I
4,
get the
also to
same
pi
R,
over
And
2.
then I get 2 pi.
Okay,
He didn't.
so,
Okay, so this is 2 pi.
Yeah, cause.
Let me
Okay, this is 2
reiterate
pi, and
why
this
they-
is 2, right?
the
So then that is
definition
one
of
integer.
of
Okay.
phi is, slightly
It's right
different
here,
here.
I don't know.
But we have it, we have
Okay,
it now,
so
right?
then,
Yes.
Okay,
this
so all you
thing
have to
becomes
do
z
is
squared over
establish
2.
that this line is 45 degrees.
This is my,
And all
my
you have
DR,
is-
I'm converting my DR.
It was a lot easier for me to establish the first time.
Yes,
we
it's
did
Yeah,
it.
not
the
z squared
intersection
over
point's
2,
not
it's 2z.
necessary. But why do they go up instead of down?
But if you find an integral for that, the integral.
It's 1/2. Or it's 3/2.
3, yeah, it's 9 minus r squared to the 3. So it'd be 2z times that all over 3,
Mm-hmm.
but then there's still that r problem. So that has to be,
Well, isn't it written by Z first?
yeah, she did z first,
I
so
did
she
z
got
first,
ZR.
ZR, and then that becomes that, and then your DRD theta.
Wait, what?
Cause you switch out your, no, this is supposed to be R.
Yeah, that's,
There you
okay, that
go.
makes
There
more
you go.
sense. Oh, well, then that makes that easy, so that, for, when you integrate that, that r goes away, and there should be a negative sign in the front. And I think it should be over 6. So,
Because
no,
that
I'm saying the full
becomes-
integral of this That is negative 2 this over 6. So
Like that?
that's what the full integral
Oh.
will equal. You're gonna have to evaluate at 0 on the screen. And do you agree?
I got R.
No, I'm saying the full integral after everything's done with the integral of that will equal.
R equals, you're here,
Yeah.
and
So
then we go here,
so pretty much I'm just
R,
I'm just
this is R, minus, or R times.
no I'm talking
square
about
root.
integral right now. So that's what I'm saying.
Well, but this
Can
would
I
be
tilt this board, do you
3/2.
guys mind, please?
No,
Yeah,
she's
because I-
doing it step by step. What I'm doing is I'm just going straight into what the integral is.
Yeah.
Yeah, I am too.
So the actual integral should just be
9/2, this is 1, this is R, well, this is R right here,
Yeah,
this is R
this-
squared.
no. The thing is
Okay,
on
Stuart.
the integral.
We uncovered something,
Okay.
another,
When you find the integral of this in R
you
half,
didn't read the problem carefully enough.
which that one would have
So
happened.
could you read the problem again,
So integral of
very carefully?
9
Okay.
minus R squared to the 3 halves.
Here.
Well, no, R can't come out.
No, that's because that was going to.
Oh.
Yes.
So the R will come out.
So phi is correctly defined as coming down from the z-axis. So,
No, 'cause I think,
yeah, that's what they want. They don't want what you want.
So,
Yeah.
So shade the area that they want
Yeah.
D theta.
in
Oh,
the
yeah,
drawing.
yeah, that's why you're doing d theta. If you were doing dr, well then if it's d theta, theta just
No, the drawing's good, just shade it, shade under the cone.
2 pi r.
Okay, so then this is wrong.
yeah.
So,
So pretty much
well, you know, all you do is shade down there to the xy plane, that's what they want. Yeah.
no 2 pi
I mean,
is
well,
0
no,
to 2
because
Phi
pi.
is
I'm
measured
down
down
anyway.
from the
This-
z-axis.
I gotta redraw it.
All right.
But since there's
redraw
no
it.
pi,
So we'll look at
you don't
20.
even worry about the pi.
Oh,
Since there's no
20.
d, I mean d.
No, but
d
since no d
theta.
theta, you just add d
Yeah.
theta to the end of it.
Yeah.
But we're doing it
oh,
from
you did
Zero to
spherical
2 pi.
coordinates, that's cute.
R squared
Okay.
and theta,
yeah. We're not doing it from 0 to 2. We're doing it from 0 to 2 pi.
and then 2, yeah,
Yeah, so this pi here and then here.
yeah, 2 pi and 0.
So they give you 2 pi r thingy.
Oh, because my pi is in, okay, and then 9 minus R squared,
Okay.
right?
Yeah. Now you
Yes.
find.
Okay, now I'm on this last one.
Yeah.
Okay, so then this gets integrated, my R does,
Okay.
so it's 2 pi R
No,
squared.
you don't have R
So,
squared, it's not.
Stuart is repairing,
This R?
and
Yeah.
illustrating
As I
very
said a while
carefully,
ago,
that's a nice
okay,
drawing
so
now,
let's do
that
this. If you
the
take
angle
the
phi is
derivative
measured down
between-
from the z-axis, not
The
up from the
derivative of
xy
that?
plane.
It's 2R.
It's a dog dish.
No,
It's a
the
dog
derivative
dish, and
of
that's
nine minus-
Beautiful
Oh,
drawing
half.
of dog dish,
You get a
certainly in
half,
my top 10.
and then you
And here's
open in
number 20,
this
which he
R
chose to
minus-
do
or
in
9 minus 2,
cylindrical
and then
coordinates.
half, right, it's a negative.
And
But
here we
also
have
it's not
AJ's
because
quick
you have
check
stuff
number
that
2,
Yes.
AJ's
So
number
same-
5,
So this, the R cancels out.
The R will cancel out in the full integral.
and
So the
here
R
we have
cancels
AJ's
out,
number
so then
19.
you got the back to the 3 halves. So it's
So it's 2 pi times 9.
Now let's see what's going on the other side of the board there.
the reciprocal, so it's 2 will be 4 all over 3.
Yes.
Going to get the camera
And then we're gonna take the du of the r squared, a negative 2.
This is a negative. No, it's
The
not.
negative 2r comes out, so this would have to be to the negative, and that would be a 6.
Can I give you my ID and you can do my proctor exam for me?
And you have to do the 0 also.
cause security on this.
I would cost security to keep putting our pictures on YouTube.
Security asking.
So yeah, the final one would be negative 4 pi 9 minus r squared to the 3 halves over 6. If I'm correct.
Okay, it sounds good, RJ.
That's the negative.
Did you intentionally just call him RJ?
I mean, huh?
Did you intentionally?
AJ.
So
No, I meant to say AJ and I said
at 2 and 0, you got
RJ.
4 pi.
And you sub
7.
out to,
8 weeks
So
together.
it's negative 4 pi.
it's negative 8 times 9 minus
Where did the 8 come from?
4.
Maybe sir, you know, take the back away.
Huh? Right? That's it? No, I already did that.
So this is now copacetic, Lynn?
Where's
Yes.
All repaired?
Yes, but I did not do the integral.
That's okay. Well, let's do the camera here then.
Should be negative
Good angle.
5, this, all of it has. I did the R first.
Okay.
Before the so it looks different.
So here we have number 11,
So
which
that's-
is done by making a drawing and understand what's going on. So this is number 11.
Okay, so that's
Here's quick check number 1.
4, which is
Do you guys want do you guys want the real integral for
One
that?
twenty-five divided by.
The real integral.
You guys are doing
25.
the integral of just the square root of 9 minus r squared, right?
What are you talking about?
Yeah, that's what we were doing
Do
earlier.
you want the real
What
integral?
is it?
It
If I'm guessing going into that.
is r over 2 square root of 9 minus r squared plus 9 over 2 arc sine r over
You don't want no R sign.
3.
Nobody would give one that, you're making that up.
It's
Well, no,
number-
get,
it's
get,
number 74.
get version 10, will you?
All right.
Get the 10th edition.
Do you mind if I look at your book?
Go ahead.
So, the scroll, wait, what?
I don't know.
Okay,
We
so
were
we
right
got
here.
2 pi,
Oh,
5
yeah,
pi,
version 10 is totally different.
Well,
Pi,
yes, sir.
5.
If I do the R first here, then
So,
And that's 125.
There's a Z.
25 times 5
I can't do 3 halves, I don't even know what that is.
is 125 and then.
If you do the R first, how can you do the integral?
yes.
Well, you make a substitution,
Yes, I let U equals this.
Yeah,
But
so it should
then-
be negative 5 squared.
so it's u to the 1/2 du.
12.
Yes.
So you can integrate that, it's
So
u
that
to
gives
the
you negative
3
10
halves, right?
times 5,
So I have
So
square root
this
of
equals
R
what?
squared plus Z
negative
squared.
10 pi squared root of
Now you
5.
let U equals R squared plus Z
Oh,
squared.
That's right.
Yeah, but
So
then you still
what
have
is
to take the 0.
du?
du dr equals,
9 3
But I have
halves.
Z there.
that's a constant.
Oh, minus?
It's like a number 7 or 9.
This becomes a 0?
Think of it as a 7 or 9, it's just some number.
9 is
Oh.
729.
So to R.
That's right. That's what partial integration is,
729.
okay?
Just say yes.
That's how you do it.
I can do that part. I can
The Z is just some number.
8
On
times
that.
9 times 10 plus
Yeah.
9.
I'm only gonna 729 because 7 and 2 make
Good,
9.
so now you can do it.
So that's 99.
Well, 8 and 1,
Mm-hmm.
and then 1
As long
times
as,
9 is
as long
9,
as the
and then 8
9's
times
in
9
there,
is
it's
17.
easy.
Okay, that was my problem.
Yep.
Okay.
That's my rule for
Here's the
9s.
integral. What it should look like. You guys did 9 minus r squared, right? So everywhere you see an A, replace it with 3.
I think Stuart should get a Purple Heart for doing the course with the wrong book.
I should get what?
A Purple Heart.
I got a purple heart for being stabbed with the flag.
Stabbed with a flag.
My enemy combatant?
No, by his drill
Well,
mate.
if you.
By his what?
Drill mate.
No,
Oh.
actually, it was caused by the other school's football player who
Sure, it's-
accidentally hit the
brawl?
flag.
You guys had a brawl?
No, he hit the flag on accident, causing
On
the flag to
accident.
fall
You-
and stabbing me.
I think
You realize you're
was
going on
doing-
YouTube for
Yes.
defamation of the flag. You're just throwing it around while fighting at a high school event.
Well, I hope you suitably punished him. Okay, now we've gotten all the mileage that we can out of these guys, so now I'm gonna put the ball in your guys' court. Where do you guys wanna go, anywhere
Oh.
between 13.7 and 15.1?
I'm gonna sleep for Friday.
We wanna go home. 13.7 and 15.1, pick it. Well, we didn't do all of these, but we did enough to get the flavor.
I'm a practice
Anything
one
with
from
finding
13.8.
limits.
A practice one one.
You want
I
13,
want
so-
practice with finding limits, just so I can get that out.
Well, then you want to do some more, do you want some more spherical, or you want to go back to Cartesian? You wanna
I
do
don't think
these
I can
others,
see
8, 10,
anything
and
else
18?
in my.
These are spherical.
Ten's
Yeah,
right
he,
there.
he has.
Ten's
Okay, I'll get it right now.
No, she did.
Yeah, she did.
Quick check, 3 and 4, what about those? Now, these are spherical, are you
There
tired
are
of
no
spherical?
quick
You just wanna go back to the, earlier section that has, triple integrals?
Can you just tell us which one in this section you're putting on the test so we can memorize it?
Well,
You know what's funny about that? You're assuming that you're going to remember the right way of doing it.
Well, I'm gonna remember it the way I'm taking
Yeah,
the
let's go to
picture of it.
page, 1046.
My book's different.
Let's go to section 14.5, the problems.
How different is it? That's what I'm seeing.
No, I have all the same pages as you guys.
Yeah, that's exactly the same.
Yeah.
I never understood why they always make different editions. What changes between a year?
Money in their pocket.
So I was wondering why his was different, but I assumed it was because it was brand new and he got answered with it.
Okay.
Like I noticed from like the week one that your cover was different than mine, or whatever.
Yeah,
got
I
wrong.
noticed that too. I noticed yours was different. I just thought you just had the American version.
I got what they sent me, I didn't question it or compare it or anything like that.
So the email that you sent, I copied the ISBN out of that, went and pasted it into Amazon.com, and I ordered it.
See, I do that, but first I check what the cover looks like on the actual, web
I
sale
don't-
place.
I don't know why that matters. The ISBN. is
Well,
for-
No, it matters
That
because
should
this is
be
an
my
IS
fault.
edition.
When you
There's an
register for
international-
classes in UMUC, it automatically gives you a scrolling of all the books you need on the right-hand side.
Well, yeah, but did Amazon
Is
send
your
you the ISBN you asked for?
Oh, yours isn't.
Stuart, did they send you the one you asked
You have
for?
a 0, I have a 1.
I'm gonna have to check.
The ISBNs
email.
are
Yeah.
different here.
It could be my fault.
See, you have 11180 9 blah blah blah. You have 0470.
Yeah.
But this
It
is
could
the
be
second
my
time.
fault.
The first time it happened, I was supposed to use like edition 11 of our business book, and they sent me edition 3, and nothing was the same.
Well, yeah, it's like 8 editions later.
Like absolutely nothing was the same. So then I had to buy another copy of it.
Yeah, I assume 8 editions later would be different.
Okay, I went back to Cartesian coordinates, I don't really see anything interesting there.
Agreed.
Oh, no, we have to switch the order of integration.
I like chicken.
Okay, 14.5, number 39.
That's not that interesting.
I don't think any of it is, Stuart.
Number 39A.
39A. Are we doing it all on the board or as a group?
I just wanted to make sure
Your
I was
choice. How
able
would
to
you prefer?
find the limits.
No, just do it on paper first, to see what's worthy of the board. 39A, they want you to do the Z integration first, the Y integration second, and the X integration third. So this is interchanging the order of integration. For those of you that have a certain textbook, it's on page 1047. And that's probably my fault, they probably sent you the ISBN. I just passed on the one that Maryland gave me.
I've been reading the book this entire time. It's just been the wrong book.
Yeah, you showed me.
I never trust page numbers anyway.
Well, he's never gonna trust me anymore. So the 39A, we swap out the orders of integration.
So, Z first, Y second.
Okay.
last.
Now, I really recommend, once again, a drawing to indicate what this beast is. Once you have the drawing, then you have to invert the functions. So be sure to label each boundary by the appropriate function, and then invert them as necessary.
Why am I in this weird arctangent page?
Oh, because that's the right integral. Weird. Let's just make it up. Like what you guys put down looks nothing like that.
I don't trust that.
You don't trust the book. It's an
You
integral.
don't trust the book.
What do you mean?
My book is perfectly fine.
I got the integral out of the back of her book.
I trust my calculator.
Do that integral on your calculator, and it's going to give you the same thing.
Okay, who's got a picture for 39A? What's this thing?
I'm still trying to visualize what the square root of a square is.
Yeah, give me a picture. Give me an object.
On what page are we on?
1047 in certain books.
And everybody else is but Stuart's.
No one cares about arts.
Okay, so what kind of object is this? What's its shape?
Is it a circle?
It's a three-dimensional object. Circle's not a three-dimensional object.
Oh, sphere.
It's a half cylinder.
Yeah, I gotta have.
Not a half cylinder.
It's not?
Oh, 0 to 2. Oops, beg pardon. half cylinder
Then it
wings.
would have to be on top, yeah.
It's a half cylinder, right?
Mhm.
So you take a can like this and you slice it down the middle,
Well, I have a quarter cylinder, but.
you slice it down the middle, right? It's half of it. Just peel it into two pieces, okay? Straight down the middle.
Well, actually, it's minus wise, but
So,
I'm on the wrong axis here. I'm on the wrong axis.
looks like this, agree?
Yes.
Okay, now you gotta, is it centered on the origin? I think it is centered on the origin, right? So now you need the, you have the picture, so if you get your dimensions, and where is it? Z is 0 to 6, so it's up, and Y is 0 to 2. So it's up.
So it's only a quarter?
No, it goes in the back too.
Oh, it goes to negative, okay.
Okay, so we have this object, and it's coming out here to 2, it's coming down here to 2, and it's going up there to 6. So now, if you interchange the limits of integration, then this circle here is x squared plus y squared equals 4, true? So you can solve it, you can resolve it for the other integral. You can either solve it for x or solve it for y. So Lynn, what are your new limits of integration if you do z first? So what's the limits on z?
0 to 6.
0 to 6, that's not gonna change, all in favor?
Yes.
Okay, now they want to do the y integration second. So what are the limits on y? You have to solve the boundary equation for y. So you found the boundary equation, so solve it for y.
Plus and minus 4 minus x squared.
4 minus x squared, agreed? Good, so that's the y limits. Now what are the limits on x as the last?
X equals plus
Negative
and
2 and 2?
minus square root of 4 minus y squared.
No, the x integration is last now.
So is it negative 2 to 2?
It's, no, it is, except I drew it wrong because it is this first quadrant, isn't it?
So it's from 0
It
to
is
2.
this one quadrant, true? It's just in the first quadrant? All in favor? So 0 to 2, it's the first quadrant.
Okay.
It's not half a cylinder, it's a fourth of a cylinder.
Who did you listen to?
Well, I said at first it's a fourth cylinder when you were saying it was a half.
I have the wrong book. Like,
Why don't you let NJ, do it? Okay, B,
E?
let's by all means draw this shape. So the y integral goes from 0 to c. So that goes from y equals 0 to y equals z. Well, that's just a straight line, 45 degrees. So y equals z is just some straight 45-degree line. And then 0, the z integral goes from 0 to 3 minus the square root of x. 3 minus the square root of x. So let's just solve this z squared. minus the square root of x. So when x is 0, z is 3. So let's draw this in the x to z plane. So when x is 0, z is 3, and when x is 9, z is 0. So apparently it looks like that. And say when x is 4, z is 1. So this is what this thing looks like. It's a square root function. And the other one is 0 to 9 for the z, for the x-axis, 0 to 9. So it just goes out to 9. So y starts at 0 and it goes to z, and zx, z is 3 minus the square root of x. So this looks like that. Goes up to 3. And so this is a cylinder in the y direction. Because there's no y involved. And then this other plane, y equals z, is also a plane, because there's no x involved. So it's a plane that comes forward. Okay, so, and it goes through the origin, and y goes from 0 to z, and x goes from 0 to 9. Okay, so I've got my picture.
Some sort of weird shape.
It's a wedge of cheese, agreed? It's a wedge of cheese.
Maybe it's spherical.
No, this goes, this
Looks like
slices.
half of a
No,
canoe,
this slices,
half of a boat.
this slices straight down. So it's a slice. Okay.
Is that top part rounded? That top part is rounded.
This is rounded.
Yeah.
Okay, so this is the equation z equals 3 minus the square root of x. So this is the plane z equals y. And the back surface is just straight. So how far out does it come here?
Oh,
Well, z goes up to a maximum of 3, so z equals y, it comes out to 3 also. So now we can invert the equations, agreed? We have the drawing, because y clearly goes from 0 to 3, z continues to go from 0 to 3, but now there's a new relation between z and x. You have to solve this equation for x. How do you solve this equation for x? So z minus 3, or 3 minus z equals the square root of x, and you square both sides. And squaring both sides is going to produce 9 minus 6z plus z squared equals x. So that's a new equation for x that you get. So,
I don't
X
know
should
if you
stay
have
the
to do that.
same from 0 to
don't have to do that?
No.
No, X should stay, we're only switching dy and dx.
They interchange dy and dx?
Yeah, x, no, dy and dz, dx stays the same.
Well, don't have to do that. Looks too easy. Okay, so what about number C? Let's go home problem. Do C and we're out of here.
Oh my gosh, it's so complicated.
48 more hours, just hang in there, dude. This will be our last problem in this course. Number C. Don't get nervous.
All we're
Now-
doing is changing our integrals, right?
Yeah, but you have to recast one of the functions, you have to invert the functions. Now, they want the z to be performed first, the y second, and the x last.
Yeah, so your
Okay.
z is the 8 minus y and with the y as the minimum.
Okay, now first x is going out to the square root of 4 minus y.
So that's x, so that goes to the end now.
So what we wanna do is, that's x equals, square root of 4 minus y. And next comes z equals 8 minus y.
Yeah, but that one's first. It
So,
was-
now the z integration starts at, currently at y. The y integration goes from 0 to 4. I'm not able to do this without a drawing. I can't do it by straight limit swapping. You guys are saying that you can, so you can't. Can anyone do this by straight limit swapping?
Well, I thought the dx, dz, dy that express like in C. I thought all you were doing was moving them around.
No, you have to change the limits. The moving them around is easy, but then you have to find the new limits that will cover the volume. You have to cover the volume in a different order, so that your stopping points are different. You just have to be sure you cover the volume. So I can't really do it without a picture. So dx is going, the square root of 4 minus y is x. X equals 0 to 4 minus y. What kind of equation is that? So that's a parabola, because,
I think the operator term is a half a bluff.
a half a parabola,
A half a bluff.
half a what?
I'm tired. That's a joke. Half a parabola, a half a bluff.
I'm tired, I'm laughing. So, x equals 0, we don't have any argument with that. X equals the square root of 4 minus y. So that means x squared equals 4 minus y, or it means y equals 4 minus x squared. And what that is an upside down parabola that starts at 4. So we've established the relation between y and x, true? Good. Now let's try to establish connection between other things. The z integral goes from y to 8 minus y. So we have z equals y, and z equals 8 minus y. So this inverts to y equals 8 minus z. These are just lines.
It's only half a parabola, because y's limits are from 0 to 4.
Yeah, okay, I'll get there, I was just throwing stuff out. Okay, so, the relation between y and x is a parabola, and the relation between y and z is a plane, and the relation, well, it's still a plane, it just goes from 0 and stops at 8. So, this is a plane, and it doesn't have any, x in it. So, we have a parabola, and then we have a plane that cuts the parabola. And the third limit is, 0 to 4. And that's going to be y. Y goes from 0 to 4. So that's 0 to 4, so there that is. So y goes from 0 to 4, that's established. So if y goes from 0 to 4, then x goes from a 0 to 2. Okay, so x has a limit of 2, because y has a limit of 0 to 4, so x has a limit of 2, 0 to 2. So we have that kind of a picture, and now let's put it together with this plane. This plane, y equals z, is a 45-degree plane in the yz direction, and it stops y equals minus z plus 8. Z equals y is 45 degrees. Y equals minus z is minus 45 degrees. Goes down 8. So this is looking like that. Y equals minus z plus 8. And z equals y looks like this. Z equals y. So we have these two boundaries as well. And then we have the paraboloid. So there's these two planes, z equals y and z equals minus y equals minus z plus 8. And these two planes, this paraboloid, this parabola, which has no z, what does it mean for a parabola to have no z? That means it's a trowel. It's a cannon, because it has no z. So that means it has 3 dimensions. It's like that. It's a tunnel. Okay? So it's a tunnel in the z direction. And the limits in the z direction are the plane z equals y, which is 45 degrees. It's going to come down like that. Z equals y. Okay, that's going to cut that. And then the other plane is going to be minus z. Okay, getting close now. Y equals minus z plus 8.
It's like not Pictionary, this is for real.
No, I actually think I know what it.
Yeah, I think I have a picture of it.
I'm not seeing this picture.
Nope,
I drew it.
you drew it.
I drew it. So here's the y axis, here's the z. 4, 0, this point right here. I guess there's that for z. And so this is 2.
Yeah, let's do it again.
So that's the tunnel created by,
The parabola, yes.
and then there's that and that.
Y equals z, yes, that's what I was getting at. Yes, I was going there. Right, and, yeah. That's it. Absolutely right. And,
Wow.
this and this, now, is this plane, is the back plane is also a wall, right?
Yes.
Okay, good. So, yeah, that's it. And the other plane, then comes up like this.
Collecting art really paid off for me.
Okay. So, now, going from the drawing, we can get our new limits.
Where did that canopy come from?
I'm kind of feeling
Cabela's.
Okay, now we can get our new limits. What's the first one they want us to do first?
DZ.
DZ?
Yes.
Okay, so from your drawing, Z is from 0 to 8?
Yes.
And the next one they want us to do is?
DY.
DY.
And,
Actually, but DZ is it changes because so it goes from y to 8 minus y.
yes, y to eight minus, or eight plus or minus or plus?
I
Eight
have,
minus
I
one.
have 8 minus y.
Well, the original equation was, z equals eight minus y. Okay, I see what you're saying. Okay, so now what they want you to do next is the y?
Yes.
Well, that's easy, because all you have to do is convert x and y. So y goes from where?
0 to 4.
Zero to four.
No,
0 to 8.
no, 0 to 3.
0 to 4.
Four minus
You
x
had
squared.
four as the top of the parabola.
Yeah.
Okay. 0 to 4. Now tell me within what x goes.
0 to 2.
Well, this can't be right, because we haven't used the relationship yet that,
So it has to be,
that x
in
equals
the
the
middle.
square root of 4 minus y. We
Oh,
haven't used the
yes, you're right.
relationship that x
Ah.
equals the square root of 4 minus y.
yeah.
So we have to change this
minus
y
x squared.
relationship to x squared equals 4 minus y. So y equals 4 minus x squared up here. Okay, divide by it. Done. Then do that now.
I'll accept your update.
Okay, next item, test. See you then. 4 o'clock.
4 o'clock is when it's starting?
Well, it doesn't have to. Come when you want to.
I know,
No
but
later
4
than
o'clock,
6:15.
4
I'll
o'clock
be
is
here
the
at 4,
earliest.
yes.
Okay, that's what I meant.
Enjoy.
And you'll be here till 4 in the morning, right, the next day?
Sunday. This is it.
I've had a horrible headache all day.
Really?
And I'm glad to say that calculus hasn't made it worse.
How in the world are you?
My headache just started now since class ended. My head was full of happy thoughts, now it's just hurting.
What incited these happy thoughts?
You just got a girlfriend.
No, get off him. He's smiling.
No, it's for my trip to Tokyo.
He's growing up, he
It's
got
my trip to
taller.
Tokyo and I'm turning 20 in a couple weeks.
Hours?
So 20 in a trip to Tokyo by myself. Put two together.
You're going to Roppongi?
No, he's avoiding Roppongi.
You're
Yeah.
20 years old.
You're gonna discover the world.
It's like going to Tijuana. I would do it.
What happens down in Roppongi stays in Roppongi.
Yeah, right?
You're a slow learner, Monica.
Bye.
Have a good night.
Good night, guys.
I did my Tijuana days already.
Course is over.
Since I really have trouble seeing drawings, can I always do this, like to find my dy, I just solve for y since I have x equals this?
I am 90% certain that you can just do that, yes.
90%.
90% certain,
For
yes.
this, I let y
Yes.
equals 0.
Right, yes, I'm 90% certain you can just do that. Yes.
Because I really have terrible seeing.
I'm not far behind you. I failed also on this drawing. I did not finish it on the drawing. So yeah, just go ahead and do that.
It is.
Yeah, absolutely.